Okay, so I just recently acquired these three classics. We've got a Classic 1 and two Classic 2s. The Classic on the Classic 2 on the far right apparently is working, but to my knowledge has not been recapped, so I'm going to recap that and clean that one up. The one in the middle is apparently a checkerboard screen, so once again I'm going to be looking at fixing that one up and getting it all ready to go. And then the Classic on the left, not 100% sure, definitely not working, but possibly created smoke last time it was switched on. So I'm not sure whether I'll have any success getting that one up and going again, but I am going to give it a try. So the first thing I'm going to do is I'm going to start with the Classic one on the left. I'm going to open it up, have a look inside, and just see what needs to be done and what the condition is inside. Now, for those who are not aware of generally what classics of this vintage look like inside, they often have goo leaking out of the capacitors or exploded batteries with corrosive material all over the board, often rusted chassis because of it, and often in very, very bad states inside. So I'm going to open it up and just see what this one looks like. Okay, well, I've got it open, and to be honest, at this stage it doesn't look too bad. Not a great deal of rust around the chassis. Plenty dusty for sure, but I've seen a lot worse. So I'm going to whip out the logic board and we'll give that a closer look. Okay, well, here's the logic board, and it has to be said that this is in remarkably good condition. Just sort of at a glance, there doesn't seem to be much in the way of capacitor leakage. The battery is still intact, and I'd be fairly surprised if this logic board didn't work as it is. So if this does indeed fit the description that that's smoking, then it's something that I would definitely expect to be at the analog board area. So I think the next thing I'm going to do is actually try and switch it on and see what happens to find out whether the description I was given for this one is actually accurate. So we'll see what happens when I throw some power at it. Okay, so I haven't actually bothered to hook up the hard drive or the floppy drive, just connected the power cable, and I'm just going to switch it on and see what happens. Dun, 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 dun. Dun 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 dun! That's the hard drive spinning up. Got no chime. I don't think there's any smoke coming. Oh! In actual fact, it's very pale, but we actually have a little background and pointer there. So I think the condition of this particular Mac Classic was slightly exaggerated, and I would not consider this one broken and smoking. I would call it working and not smoking. So I'm basically going to give it a recap, of course, because of the age of it, and then I'll clean it up and put it back together. But I think this one is a relatively easy one. The next thing, I'll have the motherboard in front of the microscope, and I'll go through the recapping process. Right, so I'm down here in my my messy little workshop. This obviously got my microscope here, which I will be showing you what I see through that in a minute. I've got my quick 861DW hot air station. I'm going to use that for removing the old caps, and then I've got my FX951 knockoff soldering iron for putting the new caps on. I have my new caps here, so I've got 7 47 microfarad 16 volt and one 1 microfarad 50 volt, and then I have some soldering wick, and obviously some solder over here as well, and obviously a big mess as well. So they're the bits and pieces that I'm going to need to do this, and the next thing I will look through the microscope, and we'll go over the process. Okay. Now, you will notice when we look at this under a microscope that areas that didn't actually look too bad before are actually looking pretty gunky. So, for instance, if we look around these capacitors here, you can actually see there's quite a bit of green and, a bit of corrosion around, and that's just a sign of things to come. If left unattended, this would just get worse and worse and worse. We've got this kind of goop going on here, kind of gooey stuff, which I assume has leaked out of these capacitors, and I've got who knows what that is. So this is all going to need a very thorough clean once these caps have been removed, and I'm going to do that in my ultrasonic cleaner. And I'll go through that process when I'm finished. But the first thing I need to do is get rid of the old caps. Have a look at the corrosion around here. You see that? So that's all going to have to be sort of cleaned up as we remove them. Now, different ways of removing the capacitors. I've seen lots of different processes. I've seen some people that have actually applied solder to one side, soldering iron to one side, and then they've tried to bend it up and then get the other side off. That's a pretty surefire way of ripping the pads off the board, and I don't recommend it at all. Obviously, if you have solder tweezers where you can apply heat on both sides and then remove it, that's fine. I don't have solder tweezers, and basically what I do to remove these is I just use hot air. Now, because I'm using hot air, we've got all these plastic bits here and there. So what I actually do is I use a bit of a shield, which is just a piece of metal that I kind of plonk over top of the plastic bits, like that more or less, so that when I apply heat, I'm not going to melt anything that I don't want melted. So I'm just going to... a fair bit of caution is also required, and then of course the other thing is if I do a little bit of melting, I don't mind too much, as long as I'm not completely and totally destroying the thing. Alright, okay, so I've got that cover on there, and that's covering pretty well. It's covering those plastic parts pretty well. So next thing to do is to apply some heat, which I will do now. Now, these do have a tendency to pop sometimes when heat is applied, and it can scare the bejesus out of you when it happens, but, because you're actually looking up into a microscope, it's not going to actually pop into your eyes or anything. There we go, there's one off. Okay, let's go to the next one. Wanting to get the... there we go, that one come off nice and easy. Once the board itself is a little warm, they start coming off a little easier. They don't take as much heating. Okay, so that's those two off. And we can see a little bit of melting going on the plastic here, but nothing terrible. I can live with that. Okay, got a couple more caps here. Don't really have anything plastic around these, so I can just whip these off without having to cover them. So let's just have a look-see there at it. Okay, he's off. Next one. By the way, the goo that leaks onto the board, when you're applying this heat to it, it doesn't half stink. Make sure you have good ventilation and extractor fans and all that sort of stuff. But the main thing here is I'm trying to get these off without causing, without actually damaging these pads, these metal pads here. I don't want to yank them, I don't want to lift them off the board, just try and get them off as carefully as possible. Okay, so that's 4 caps we got off. Still a few more to go. Now this one, these 4 that we've got along here are of course right next to this plastic connector, so I'm going to have to try and find a way of putting some protection over the plastic to the best of my ability. I'm just going to have to be reasonably careful here because I'm not able to get that covered perfectly well. Okay. Might actually tip it up this way. There we go. Okay. Get it in the camera. There we go. Here's one. And now I'm going to try and do the rest of these as quick as possible while the board is still warm. This one's a gunky one. I'm worried about what might come off with this one. But here we go, he came off nice and easy. Look at that. Next one. There we go. And last one. There we go, he's off as well. Okay, so that's those 4, and, well, one of them just popped. Remember I told you that popped? That just popped. Okay, I've got a little bit of meltage going on under here, but again, it's not going to affect the functionality. Some people might get upset with the aesthetic, but, you know, it'll all work. That's all I care about. Okay, just look at this corrosion along here. Nasty stuff. Yep. So all of this that you're seeing here, this corrosion, will be related to this stuff here. As you can see, that all this goop here is the goo that has been leaking out of those capacitors. And that's obviously why they have to be replaced. So you can have one that, like this one at a glance, just looked like it was fine, but it was far from it. Okay, so I think, let me just check. Oh, that's 1, 2, 3, 4, 5, 6. 7. Well, there should be an 8th one. Where is it? 1, 2, 3, 4, 5, 6, 7, 8. Yep, there we are. Okay, so that's all of the capacitors off. So now it's just a matter of cleaning those pads up and putting new capacitors in their place. So, oh, actually, I should also mention one other thing. This guy is not our friend. Inorganic lithium battery. Killer of logic boards. That's gone. See you later. And what is also going is this holder. Because this holder is designed for those sorts of batteries, and I can't be bothered trying to source those batteries. So what I do is I take these holders off and I replace them with little button cell battery holders. So I can just stick a little CR2032 inside there instead of using these, whatever they are, I can't remember, the N or something, I don't know, whatever the battery size is. Half AA, half AA. There you go. Half the size, twice the voltage. Alright, so next thing I've got to do is get these off. Now these are a bit of a bugger to get off in one piece. You know, because they have a tendency to melt and whatnot. I can apply heat to the other side, which is here, and pull them through. But to be honest, it's a little bit tricky without kind of wrecking other things. So what I have actually ended up doing in the past is I've ended up actually just essentially breaking the holders and then just applying heat from the top. So that's probably what I'm going to do now. I'm probably just going to snap this holder in half and then just remove these, you know, sort of one at a time. Okay, well that was not a pretty process, but it is done. I have managed to remove the battery holder without damaging these traces or pads. So I will be able to put a replacement in. Okay, so what I'm going to do now is I'm going to clean up some of these pads of the old capacitor. So let's start over here. Okay, so these ones here don't look too bad, but I'm just going to go through the process that I go through with every one of these. The first thing I'll do is use a good no clean flux, a good quality no clean flux. Got to be careful the way you say that, otherwise it makes it sound like you're saying rude words. So this is I'm using Amtech NC559 V2TF. So isn't that exciting? I'm going to get some nice new solder here, and I'm going to just sort of rub the iron around those pads just to help kind of clean away that old crunchy gunk, the old you know, sort of muck that's sort of ended up where the old solder gets all sort of hard and yucky. And then I'm going to get some wick, which I'm just going to do that now, and put the wick over there and just clean it up a little bit more. Now, by the time I'm finished with the process, those pads should look absolutely spotless. There should be no little chunky bits on at the ends or anything like that. And to be honest, that one looks pretty damn awesome. Just going to clean it up a little bit with some isopropyl alcohol. As you can see, the end of that process, those pads look like new. Absolutely clean and tidy and perfect. So just have to do the same with the rest now. Once again, add some flux, get some fresh solder, get some fresh solder, get a dog barking. Hello neighbour's dog. How are you today? You well? That's good to hear. Yeah, that's what I thought. Okay. Once again, using the wick to clean off that solder and just give a final clean to those pads. And once again, we end up with absolutely spotless looking pads, as clean as they were the day they came out of the factory. Now, if you end up with any really heavy corrosion around it, this is not a bad idea to check continuity. Just check and make sure that there haven't been any breaks in the pad that are, you know, sort of. But in this instance, I'm pretty confident with these, because to be honest, those ones didn't look too bad at all. I am concerned about that there, and I think I'm probably just going to add a little bit of solder to that on this crystal. Oh, look at that! Putting garbage onto the board. There we go. So add some more fresh solder to this. Okay, so that's looking a little bit better. I'm still not thrilled with it, but I think he's okay. Okay, so we're starting to get a little bit grubbier as we go. In particular, the areas that are always a concern are these crunchy bits around the edge. That's what we're always trying to get rid of, crunchy bits around the edge. And then again here, crunchy. So let's get this one happening again. Bloop, bloop. Now, there would be some people that would look at this and say, oh man, you use a lot of flux. Yeah, I do. So deal with it.
The main thing comes down to when you're doing this work, if you do what I'm doing here without that flux, and then you do it with the flux, you'll know why I had so much flux. It just makes the job a lot easier. So there's not enough flux on this one here, and you can see it doesn't, the way it shapes. Okay, more wick. Wick. Oh, I should mention that I'm from Australia, so we say solder, not solder. Both ways of pronouncing it are correct. If you have a look at the history of the word, both are perfectly acceptable. So you say it any way you like, and I'll say it any way I like. So I'm not going to get drawn into some sort of ridiculous conversation about one being right, one being wrong. They're both perfectly acceptable. Okay. Now, down on this one here, just this pad here, down in this very corner, there's this black stuff, and that wasn't coming off easily. So I'm actually just going to use a scalpel to try and rub some of that crap off, just to make that pad a little bit tidier. Stubborn, isn't it? Yeah. Okay, now a little bit more cleaning. I do apologise for the fact that the camera does not capture my full field of view. So every now and again I might be doing something and you can't see what I'm doing, and that's because I can actually see more through the viewfinder here than you can see through the camera. So just apologise in advance if I'm doing something and you're like, oh, I can't do that. It's not personal. Right. So what have we done? 1, 2, 3, 4. 1, 2, 3, 4. Yes, and then 4 more here. So these are the ones that are particularly bad. These are worse than any of the other ones anywhere. So I'm gonna just goop these on. Spin around that way, I think it'll be easier. Go, 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 go. Gotta love surface mount electrolytic capacitors. Okay. Working our way through. And these are the bad ones, but as you can see, I mean, even these ones do come up pretty clean once they've been fiddled with. Though I do think some of them are going to take more work than others. Okay. Doodle, 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 doodle. Okay, back to our wikidedic. Come on. There we go. Oh, that one's good. I like that one. That one's good too. Look at him. Lovely square. Or rectangle. Nice sharp edges. Okay. That's looking good. More of the same. Just getting all that gunk off. Make it a much happier computer. More gunk. More gunk. Can't help but think that I probably didn't need to show every single one of these. I probably could have just done 1 or 2, and then, in fact, that's maybe what I do on the cutting room floor. Okay. That one's come up nice and clean. That was probably the ugliest one, so that's good. And same with this one. a very fine balance with these, because you do need to provide enough pressure to get that old gunk off, but not so much pressure that you end up damaging that pad, or removing it, or lifting it off the board. Okay, but I have to say I'm actually pretty pleased with all that. They're all looking pretty good. Look at that, cleaning it up, cleaning it up. I'm not worried about, you know, cleaning the whole board, because the majority of that will be done in the ultrasonic cleaner later on. But we do want to, you know, I've got a few spots on it I wouldn't mind getting off. By the way, this thing that I'm using to clean it, in my country we call them a cotton bud, but I am aware of the fact that in other countries they are referred to as a Q-tip. So I am using a Q-tip / cotton bud to clean all that gunk off, and look at those, they just look spotless. Beautiful pads, beautiful. Okay, so that's it in terms of preparing it for the new caps. Now the new caps just need to go on. Now, for the sake of simplifying the process, as I said to you before, we have 7 of one type and 1 of another. I'm going to put the 1 on first. And the 1 is a little guy that sits over here. That little one there. Now, this capacitor, I'm just going to show it to you. This is it here. That's the little capacitor there. Now, the stripe is positive. So wherever you're seeing positive on here, that's where the stripe has to go. So I'm going to place this there. Now, a couple of different ways of doing this. You can, oh look at that, how about I put it in camera view, there we go. So as I was saying, the stripe here is positive, there's a positive there, so that's the way it needs to go on. Put them around the other way and you can be in all sorts of hurt. Okay, so if there are a couple of ways of putting these on. One way is that you can put solder onto these pads, and then you can put this on and then use a hot air gun to melt it onto the pads. I tend not to do that for 2 reasons. One, it burns the outside of these orange capacitors and they go brown. Now that's just a purely aesthetic thing. They still function fine, but they do look kind of nasty when they go brown. The other is that I just find you can get a little bit more control if you actually just solder these on one side at a time. So to start off with, more flux. Yes, that's right folks, more flux. Put a flux onto there and there. So again, this just basically helps the solder flow nice and easily. It stops it from kind of hardening on the outside and getting weird shapes, you know. It's just more of a molten material when you're using the flux. So I get my soldering iron here and I get a little bit of solder on the tip of it, like that. Not a huge amount, but some. I get this sitting in the middle, hold it down with my tweezers, and do this. Oh, see what happened? Fell off, there we go. Move it back, there we go. Okay, so. Now that, oh God, I'm making a bloody job of it, aren't I? Okay, that's now on. If I tap it, you can see that it's stuck on one side. It's not stuck on the other side. That's fine, we're going to do that next, but it is stuck on one side. It's a little bit hard to see. If I lift it up like that, you can see that that is soldered onto the pad. Because of the because these capacitors are slightly, well, they're about the same size as the space they're going onto, you don't have a large amount of the pad hanging out the side, and that's no problem, you know, in this instance, and that's why I just check to see that it is actually stuck on, which it is. Right, so the next thing I do, I'm going to solder the other side, a little bit of solder here, and like that. Now as you can see, that's melted to the, if I zoom right in here, you can see the solder is on our capacitor and it is also on the pad. So this is now soldered to the board and everybody's happy. Okay, so that's our first one. which is slightly different. All the rest, that's the 1 microfarad 50 volt. All the rest are 47 microfarad 16 volt, I think. Top of them, off the top of my head, I'm pretty sure that's what they are. Okay, so let's do another one, and we'll get some flux on there again. We'll get this, drop him again with the line on the positive, like that. As you can see, these ones here, they're a bit smaller, so we've got a little bit more room on either side, so they become a little bit easier to solder on. Once again, just grab some solder onto soldering iron, hold the cap in place, melt it on. Look at that, beautiful. Held one on one side, and then we just need to flip him around the other way because I am right-handed, and we do the same with this one. Grab a little bit more solder on the iron, and whee, beautiful, done. So 2 down, 5 to go, 6 to go. I can't count. It's all right. It's not important. Not important in my job. Okay, so just moving our way through here. Beep 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 beep. Right. Here's your plus. There. And here's another one. Here's a plus here. So, once again, a little bit of solder on the iron. In place. I'm always aiming to get these as straight as possible, because it just makes me feel better when I look at them afterwards. But to be honest, it really doesn't matter if they're not. If they're a little bit crooked, as long as they're making contact, that's all that matters. Twist him around. There's another one. And we got to make sure that heat is getting onto the pad as well as onto the capacitor. As you can see on this one, the solder's melting onto the capacitor but not onto this pad. This is a fairly large piece of metal here. It's obviously taking a lot more to heat it up. So, and I might even need a bit more solder on that for that reason. So I'll just get that there, and I will go this won't be the prettiest, but it will work. There we go. So that's well and truly on. And then we just need to do the same on the other sides of these. I'm going to have to tip that around that way. Here we go. Oh, beautiful, beautiful. And there's another one. Come on. Beautiful, beautiful. Look at that. Okay. 2 more on, and then we've got our 4 across the middle here. I'll spin them around that way, and I'll probably solder one side of all of them, and then I'll solder the second side of all, flip it around and solder the other side. So, goo, goo, right. No, positive on the right. Right. A little bit of solder. A little bit of solder. Whenever you're looking at your hands through a magnifying glass, they shake. The shaking is multiplied like tenfold, so it always makes your hands look like you're an alcoholic. So I'm probably not an alcoholic, but my hands do shake like they are. There we go. Okay. Okay, there we go. A little bit of solder on the soldering iron again. Get him as straight as possible. Boop. There's that one. Let's do another. Getting our way through them. Positive on the right again. Bloop. Bit more solder. And last one of the first side. Boop. There's a pigeon outside my window at the moment. Having a good old chat with another pigeon. Alright, now let's just get the other sides done. We've got another one here where it's solder's being a little bit stubborn. I have to push this down because I think it's leaking underneath it. Here we go, look at that. Oh god, that's good. Yep. And another one. Okay. And then last one. Okay. Now, from my perspective, that's the recapping complete. So we have, I always give a double check to make sure that I've got the plug. I don't like the look of that joint. Don't like the look of that joint. A bit more flux. If in doubt, more flux. There we go. Better. Still not perfect. Better. Okay, they're alright. I might get a bit more solder onto that one as well. There we go. Okay, so still not like that, John. There we go. Alright, so I always go through and with every one of them go and check the polarity to make sure that I didn't just accidentally stick one on the wrong way. They all look good. That's fine, that's fine, that's fine, and that's fine. So looking at all of those, that's a successful recap. Okay, so what I'm going to do now is I'm going to chuck this into the ultrasonic cleaner, clean the rest of all this goop off and any of this excess flux, and then after that I'll give it a bit of an inspection just to see if there's anything else that needs attention. You know, if there's any joins or anything that look a little bit ugly, I might go in and clean them up. But for the moment, that's basically it. The recapping itself is done, and then I will, once it's all clean, I'm going to then put on my my alternative battery holder, which is going to go on here, and then hopefully it will all be ready to go. So now let's look at the ultrasonic cleaning process.
Okay, so this is my ultrasonic cleaner. It's not a particularly good quality one, but it does do the job. So I am just going to take the lid off. You can see there's my nice clean water inside. This is basically just distilled water inside mixed with a special computer, PCB cleaning, ultrasonic cleaning solution. It's just diluted inside there. It stinks. But when I drop it in there, the ultrasonic uses cavitation as a process of cleaning, which is where it gets right into all the little nooks and crannies. And in theory, it will come out absolutely spotless.
So here is my board. Now it might seem extremely counterintuitive to be sticking something electronic into a bath of water, but of course as long as it gets well dried before I run power to it, there's no problem. So I'm going to pop them in on that side, and I'll just set the time, come on, and on. And that's the glorious sound of an ultrasonic cleaner being ultrasonic. And we'll come back when it's finished. Okay, well this is the Mac Classic board. I have finished cleaning it and recapping it, and it's actually come up looking really good. I don't really think there's anything else that needs to be done to it, hopefully. As you can see here, I have replaced the battery holder with a button cell holder. And I'm just going to sort of pan down here. You can see the new caps in place, and all of the joints are looking good. I'm pretty happy with the way that's all come together. I don't think it needs any further work on the board. So I still haven't plugged it in with the new caps, but I'm about to do that. But that's the finished product. As you can see, the ultrasonic gets it pretty spotlessly clean. So now we plug it in and we'll see what happens. Okay, I haven't put the back on yet, but I have put the logic board in. I have connected up the hard drive and the floppy drive. I've even connected up a keyboard. See how optimistic I'm feeling? So I'm now going to apply some pressure to the power button and switch it on. Okay, well we still didn't get a chime, but I did hear the floppy drive do its thing, and I did hear, and I can hear the hard drive spinning up. And yeah, okay, the screen has come alive. Let's see what happens if I move the mouse. Oh, well, here we go. Moving the mouse. Oh, and look, we even got a happy face and a welcome to Macintosh. So I've got some geometry issues with the screen here, which I'll need to resolve. That's fine. And I need to try and work out why I'm not getting sound. Typically, I would have expected after the recapping that the sound would come back. I've also got a bit of a flicker in the screen, so that's probably related to an issue with the analog board, but not going to give up on it just yet. I'll let the screen warm up a little before I start playing with geometry, because sometimes it can change as it warms up. Okay, now this is not actually my data, so hopefully we don't come up with any private information for the previous owner. Okay, now I'm going to see if I can brighten the screen up here. Control panels. I'm using the brightness. Brightness. Okay. Oh, that's good. Okay, well, about this Macintosh. Mac Classic, 4 megs of RAM. There we go. We're running System 7 on it. Let's see if I can make some sound happen, which I'm not terribly confident about. Sound. Yeah, okay, so we're still without sound, which is something I'm going to need to try and resolve. But for the time being, at least we have a computer that boots, and the sound will be the next step. Okay, so after recapping this Mac Classic, it had no sound. So the next thing I did was I whipped off the analog board and found lots of leaky capacitors. This little cluster of capacitors that you see down the bottom part of the board here, they were all leaking, so I replaced all of those and a few others on the board that weren't looking too crash up. All in all, I think I replaced about a dozen. Still no sound. So I decided to whip out the analog board again, and it turns out it was a busted speaker. If I run my multimeter on this, it's open line. This is a 63 ohm speaker, so I should be getting about 63 ohms resistance running through it, and it was open. So this speaker has been blown, probably blown at some stage because of those dead capacitors in there that have now been replaced. But yes, so this speaker was royally buggered. So I have not been able to source a replacement that is the same, as I say, 63 ohm 0.25 watt. I think the only way to be able to get one of these days would be to pull it off another board. What I did find though is I had a 16 ohm speaker on a busted LC board, so I ran that with a 47 ohm resistor in line to give it the 63 ohms that it should have. And I have, if I switch him on now, you can hear there's a little boop. Now it is faint. It is not as loud as it should be, and that's because of the different speaker in there. Now I will probably look to try and source the correct impedance speaker for it, but in the meantime at least it is making sound now, albeit a little quiet. So for the moment I'm going to put this one back together and consider it a finished job. Actually I'm going to pop a new hard drive in it too, because this is an old, what is it, Quantum Pro drive, I think. I'm not sure of the capacity, but it doesn't sound too crash hot, so I'm going to get rid of that one. So I'm going to replace that with a new one. But apart from that, I basically consider this to be a finished product. Unless, of course, I come across the correct speaker, in which case I'll replace it so that I can bring it up to full volume again. Okay, that's pretty much it for this one. Okay, so here's the Mac Plus, all put back together again. The sound has been fixed. It's all been recapped. The floppy drive works. That flickering is just happening because of the camera. The screen is actually fine. As I mentioned, the audio is a little bit sort of quieter than it would have been with the original, but I'm just going to demonstrate here. Put on the old studio session. And as you can hear, it's still blasting out at a pretty fair volume. Yeah, I'm not overly concerned about the about the sound. I may, if I do get a hold of an original speaker, I'll replace it. But for the moment, I consider this one a job complete.